Presenting on the fundamental mechanics, where we will dive into the core concepts of motions and forces. Mechanics is a branch of physics that helps us understand the world around us, from how objects move to how they interact with each other. It plays a crucial role in everything we do, from designing machines to understanding the forces at play in the natural world. Let's get started by exploring these fundamental concepts. What is mechanics? First, let's ask ourselves, what is mechanics? Simply put, mechanics is the branch of physics that studies the behavior of the objects in motion and the forces that cause or change their motion. It helps us understand not only how things move but also why they move the way they do. Mechanics gives us the tools to predict how objects will it behave under its various conditions, and it's essential for everything from engineering to everyday activities. There are two main branches: classical mechanics and quantum mechanics. Branches of classical mechanics. Mechanics can be broken down into four major branches. Number one, kinematics. This branch is concerned with describing motions without considering the forces involved. It focuses on concepts such as velocity, acceleration, and displacement, answering questions like how fast is an object moving and where is it at a given time. Number two, dynamics. Dynamics goes a step further by studying the force that cause motion and the effects of these forces on objects. It explains why an object moves or remains stationary based on the forces applied to it. The famous Newton's laws of motion fall under this category. Statica. Statics. It's statics. Statics deals with objects at rest or in equilibrium. It examines how force balance out when an object is stationary or not accelerating. For example, analyzing the stability of a bridge or the forces of acting on a building would involve principle of statics. Fluid mechanics. Fluid mechanics studies the behavior of fluids, liquids, and gases and how they respond to force. It helps us understand how fluids flow, how pressure is exerted, and how branches interact with fluids. This branch is essential for fields such as aerodynamics and hydrodynamics in the design of pumps, turbines, and even weather systems. Together, these four branches gives us a comprehensive understanding of mechanics, from the motion of solid objects to the movement of fluids. Now let's talk about the laws of motion, often referred to as Newton's law, which are the foundation of classical mechanics. These three laws were formulated by Sir Isaac Newton and explain the relationship between an object's motion and the force acting on it. Number one, first law, law of inertia. An object will remain at rest or in information or in uniform motion unless acted upon by an external force. In other words, things don't change their state of motion and on their own. They need a force to make them do so. Second law, F equal to ma. The force acting on an object is equal to the mass of an object. Uh, it could be multiplied by its acceleration. This law quantifies how much force is needed to move an object or change its motion. Third law, action and reaction. For every action, there is an equal or opposite reaction. This means that forces always comes in pairs. If you push on something, it pushes back with same force. This law explains a wide range of phenomena, from the motion of everyday objects to the movements of planets in the space. Work, energy, and power. Let's now turn to the concept of work, energy, and power, which are closer related to forces and motion. Work is done when a force is applied to an object and the object moves in direction of the force. The amount of work done is calculated by multiplying the force by the distance of the object moves. Energy is the capacity to do work. There are many forms of energy. The two important ones are kinetic energy, the energy an object has due to its motion, and potential energy, the energy stored in an object due to its position or condition. Power refers to the rate at which the work is done or energy is referred. It tells us how quickly energy is used or work is accomplished. Power is calculated as work divided by time. This concept helps us to understand how forces translate into motion and how energy is transferred and used in various systems. Concepts of forces and torque. At the core of mechanics is the concept of force. A force is a push or pull that can change an object's states of motion. Force is responsible for speeding up, slowing down, or altering the direction of an object. One important concept related to force is torque, which is a measure of how much a force acting on an object causes that object to rotate. Torque depends on both the amount of force applied and the distance from the point of rotation, like the pivot point. Torque is essential in understanding the operation of tools like wrenches, gears, and engines. Both force and torque are fundamentals to mechanics, influencing how objects move and how they react with each other. Applications of mechanism. This mechanics is also used in engineering for designing machines and vehicles. It also helps in the sports science that improves athletes' performance. It plays everything and a role which helps us in to explore this robotics and space exploration. Conclusion. The foundation of physics and engineering is the main composition of mechanics. It's many laws, such as the Newton laws, motion forces in our daily life, whereas the innovation and the technological advancement also helps by understanding motion, keeps exploring physics to see how it shapes the world. Thank you.